Okay, 2015 Day 2 Part 1. I was told there would be no math. The elves are running low on wrapping paper, and so they need to submit an order for more. They have a list of dimensions, length L, width W and height H of each present, and only want to order exactly as much as they need. Unfortunately, every present is a box, a perfect right rectangular prism, which makes calculating the required wrapping paper for each gift a little easier. Find the surface area of the box, which is 2 times L times W plus 2 times W times H plus 2 times H times L. The elves also need a little extra paper for each present, the area of the smallest side. So for example, a present with dimensions of 2 by 3 by 4 requires 2 by 6 plus 2 times 12 by 2 times 8 plus that equals 52 square feet of wrapping paper plus 6 square feet of slack for a total of 58 square feet. A present with dimensions 1 by 1 by 10 requires 2 times 1 by 2 times 10 plus 2 by 10 equals 42 square feet of wrapping paper plus 1 square foot of slack for a total of 43 square feet. All numbers in the elves list are in feet. How many square feet of wrapping paper should they order? Right, let's have a look at the puzzle input. Right, so it's a list of presents. That's it. Great. So if we go and put that in our puzzle.txt. There we go. And their sizes. So what I feel we'll need to do... Oh, let's go and copy the tests in here, the test cases first. Whilst we're here. So 2 times b by 4, and we should be getting 58 square feet, and we'll copy this across, and there we go. Test B should be 1 by 1 by 10, and that's 43 square feet. Okay, so that's our tests. What should we do? So I think we will create a present struct, so that's like an object or class in other languages, and we will implement the functions within that. So we will give the present a string, it will unpack it within creating that, instantiating that present, and we will then be able to then calculate surface area and the additional wrapping paper required. So let's do a struct called present, and it's going to have, let's say, have the sides, and we're going to have 3 sides, and we know they're going to be 3 of them, so we can use an array. So there we go. So view 32s. We could do the areas, and the same again. We're going to have 3 of those areas there. You know, L times W, W times H, and H times L. And I think we're going to do then we can then do a function to calculate the surface area and the additional wrapping paper, which will be should be the minimum of the areas. Right, so let's do implement that present, and we're going to do fn new, and it's going to take in a string, because we're going to pass the input and just pass it to the function, and it's going to return itself, an instance of itself. Right, so first of all we need to split, I believe. Let's have a look at the puzzle. Was it? Yeah, split on X, I think. So assuming it's one of those lines, we can do, let's say, items equals s.split on the pattern of X, and then let's say let's go with side 1 equals items dot next dot unwrap. So we assume that we're going to get a stir. So yep, so we've split on X. So items is now a list of strings, an array of strings effectively, we're going to go and iterate through those. So we're going to take the first one, unwrap it, assume it's a stir, and we're going to pass it and say that we can actually pass that. Again, we're going to trust that the data is fine. We're going to pass that as a U32. And we're also going to unwrap that, so we're going to expect that's absolutely fine. We shall copy that and then do that 2 times over, or we could, I mean, we could make this quite a bit nicer. So we could do, let's make an array. So let sides equals 0, 3 zeros. I'm going to say the U32, 3 of those. So then we can just pass those into when we instantiate the present. And we're going to then just do a for loop. So for in 1, 2, 3. So we loop 3 times. And what we're going to do then, we'll take that I. Let's take the index, and we can then say sides I will equal, and if we copy this across, then we just take the items.next.unwrapped pass and just put it into sides. Oh, it's not like, oh yeah, because we're not returning self yet. So we can then put that into sides there. What we also need for sides is the lengths of the areas. So now we've got the sides already calculated there. We want to go through and determine the areas, and that, I think I'll just go and do it manually. We could try and loop through it, but if we just do areas equal an array of sides 0 times sides 1, and I'll just copy and paste this twice over, and semicolon to finish that off. And then okay, so sides 1 to 0, 0 to 0, 1 to 1, 1 to 2, and of course 2 to 0. And then we've got the areas. Fantastic. Right, what's it not liking now? Oh, these are not mutable. So mute. Okay, and that also needs to be mutable. Okay, so that's going to instantiate our present. So let's say in our solver we're going to go for each line in input.lines. So that's going to split on new line characters for us. We are going to then create let present equal present new, and we're going to pass it the line stir, and it's going to create us a present. Now we want to use the sides and the areas to calculate our surface area. I think it's not going to mind that we actually keep the sides, because we're not going to use them any further. We're just going to use the areas. So let's have a function here called surface area, and it's going to have a reference to self, and it's going to return a U32, and this is, what is it, 2 times each of the areas. So we could do like return, oops, area 0 times 2 plus, I'll just copy and paste that across. There we go. Something like that. So yeah. Oops, self, of course, self.area. Areas. There we go. So just copy and replace those. So that's our surface area, and then we need to find the min. Is that right? Wrap in place plus the slack, which is the area of the smallest size. Okay, so we can do, let's say, let surface area. Well, we don't need to actually Cool. Yeah, but let's just do it. Keep it readable. Surface area equals present dot surface area, and then we can do let min area, or as well, let's keep it with the text, smallest area. Smallest area will equal, so present dot areas dot iter dot min. There we go. So it's going to iterate and return us the minimum area for us, and we'll just unwrap that as well. So we expect that to be fine. And of course we want to do how many total squares, so we'll need to sum them all up. So let's mute sum equals 0, and that's going to be U32, and we can then just do sum plus plus surface area plus smallest area, and then return the sum. There we go. So like you say, it's going to have a wiggle there because we're not going to use the sides, we only need to instantiate it. So I mean, we could get away with just not having it at all for now. Let's do that. So we just need the areas. There we go, we can just do that. We might need to return it. I could just suspect that could happen in part 2. So let's see how that runs. Okay, cargo test. Cool, yep, test A and B are all okay. So that's us calculating the minimum areas. Now let's try and run it through our yep, there we go. So it's run through our puzzles, and we've got a nice big number here. Let's copy and paste it into the text and see if we get it right. Yes, fantastic. There we go. So 2015 day 2 part 1 done. Right, now on to part 2. See you in the next one.